Alright, welcome back. We're now looking at question 2 of assignment C. Question 1 was a little bit long. It is a big question with a long solution. This one is not so difficult. We want to cover a large city by placing antennas at the vertices of a regular triangular network. So we have a triangular mesh network here. Two neighboring antennas are at a distance of A, the side length of the equilateral triangles building the network. So now we know that it's an equilateral triangle building the network. What point inside the triangle is furthest away from all three corners and why? Well, that would be the centroid by definition, right? So to answer part 1, you just simply recall the centroid and explain why the centroid is what it is. And that's basically all there is to question 1. Again, let's see, I can give some context here. If I have an equilateral triangle, I'll pretend this is equilateral. I actually just drew an isosceles triangle, but we'll pretend that all of these angles are the same angle. But again, okay, so the centroid is you take your angle bisectors, right, and you basically draw to the opposing side. And if I take two of these angle bisectors, I trace the point of the centroid, right? If I do this correctly, that's almost correct. So this is about the centroid over here. No, a little bit lower. Sorry, about here, right? Now, this value in an equilateral triangle, my apologies, I don't know if it's actually true in all triangles, but this is 2/3 base times height. And if the base is equal to A, then the height is equal to what? Well, the height is equal to this value here. So this value makes a right angle triangle. This is again 60 degrees. This will become 30, 60, and there's my right angle triangle. So I have my 2/3 base height. So I know that from this, which is given, I can find the base and height. So I have my base, and now I can find the height using right angle triangles. And now I know exactly the distance of my centroid, which gives me the radius of my antenna, right? Because the antenna has to cover my centroid, otherwise I don't have coverage in this network. So if we look at it from that perspective, okay, we have the answer here. Question 1 says what's the farthest point? That's the centroid. What is the distance of this point from the corners of the triangle? We have that with our 2/3 base height equation. If identical antennas are to be placed on the vertices of the triangle, so then we know that the distance from the edge to the centroid must be the radius, right? And that'll be all we really care about, right? Okay, so I guess that answers this entire question. In a sense, it also answers the next question, but we'll take a look at that in a separate video.